So welcome to this video where we're going to look at solving polynomials. So where we're going to look at includes long division. So if you have not already revised long division, it might be a good idea to go back over the long division video or revise it yourself before going through this video. Make sure you are comfortable with long division before we go on. So what we're going to look at today in this video, we're going to look at examples of how to factorize a cubic polynomial given one of its factors. We're going to look at how to solve a cubic polynomial given one of its roots. And then finally, we're just going to look at solving a cubic polynomial, so given no other information, so to work through it fully. And we are also going to look at solving a polynomial of degree 4 or higher. Now, when we get into polynomials of 4 or more, and I'm going to do an example of polynomial of degree 4, you can, and there are examples of polynomial of degree 5 and higher in your book, and the same method applies. It just keeps going, so it can be quite long and repetitive, but do make sure at least you understand the method of it, even if you don't have time to sit down and do a degree 6. Okay, so let's get into this. So example 1, factorizing a cubic given a factor. So show that x minus 1 is a factor of x cubed minus 2x squared minus 5x plus 6, and hence find the other two factors. So let's take a look at this. So in order to show that x minus 1 is a factor, we use what is known as the factor theorem, which states that if x minus 1 is a factor, it will divide evenly into that polynomial, leaving no remainder. So we're going to do that division. We're going to do some long division. So x minus 1, and we're going to divide it into x cubed minus 2x squared minus 5x plus 6. So this goes in x squared time, so we have x cubed minus 1 minus 1x squared. And then we subtract. So remember your divide, multiply, subtract. So we're left with minus 1x squared. So minus 1x here. So we get minus 1x squared. Bring down the minus 5x. We get plus 1x. We subtract. So plus, they cancel. And a minus. Minus 6x. Bring down your plus 6. And this goes in minus 6x plus 6, and then we come along and we subtract, so we do plus and we do minus. So that leaves me with 0, which means that therefore x minus 1 is a factor since it divides unevenly. So that's the first part done. Do make sure that you state this, answer the question. It says show that x minus 1 is a factor. So it isn't enough to just go into your long division. You do want to be putting in that statement at the end. So this is our answer here. So x minus 1 goes in x squared minus x minus 6 times. So to do the next part, hence find the other factors, we're going to take what we had, x squared minus 1x minus 6, and we're going to solve it. And we're going to solve that using the guide number method. So we're going to have minus 3 and a plus 2. So x squared minus 3x plus 2x minus 6. So x is common, x minus 3 plus 2 is common, x minus 3, x minus 3 is common, leaving me with x plus 2. Okay, so our factors are x minus 1, x plus 2, and x minus 3. So let's look at example 2, solving a cubic given a root. Show that x equals 5 is a root of 4x cubed minus 32x squared plus 68x minus 40 equals 0. So then they ask, hence find the other roots. The first thing we'll look at is the show that x equals 5 is a root. So in order to show that it's a root, we're going to sub in 5 for x. So we have 4, 5 to the power of 3, minus 32, 5 squared, plus 68 by 5, minus 40 equals 0. So you can put that all into your calculator, simplify if you want, and you will get 0 equals 0. So therefore, x equals 5 is a root. So if we are given x equals 5 is a root, from this we can get a factor. So we know that x minus 5 then equals 0. Therefore, x minus 5 is a factor. So this is covered in more detail where in the video where it's looking at factors, roots, and sketching and drawing polynomials. So if you're still a bit unclear about roots and factors, that might be a video to watch to get a little bit of extra help on that before coming back here. So x equals 5 is a root, so x minus 5 is a factor. So in order to find the other factors, we must first divide x minus 5 into, so 4x cubed minus 32x squared plus 68x minus 40. So we have 4x squared, so we get 4x cubed minus 20x squared, and we subtract or change our signs, whichever way you want to talk about it, minus 12x squared plus 68x, so that goes in minus 12x times, so minus 12x squared plus 60x. So again, change our signs, we have a plus here, a minus here, so we're left with 8x minus 40, and this goes in plus 8 times, where I get 8x, and 8 by minus 5 is minus 40. So again, you want to change your signs, and we are left with 4x squared minus 12x plus 8. So basically, the polynomial we were given can be rewritten as x minus 5 multiplied by 4x squared minus 12x plus 8. However, although we have two factors, one of those factors, and it's really this one here, is actually a quadratic, so it could be factorized further. So let's work on factorizing this further. Minus 12x plus 8. So our guide number here, so we're going to have a plus 32, and the factors of plus 32 that will work for us are minus 4, minus 8. So let's rewrite. So we have 4x squared minus 4x minus 8x plus 8. So 4x is common, x minus 1, and minus 8 is common, x minus 1. So x minus 1 is common, and then we're left with 4x minus 8. So we want to find the roots. So at this point we have the other two factors. So we have a factor is x minus 1, and another factor is 4x equals 8. But remember, this should equal 0. So we work on getting our factors down to our roots. So how we do that is we let each factor equal 0. So x equals 1. 4x minus 8 equals 0. So 4x equals 8. X equals 2. So the roots, and I'll just write it up here as our solution. So basically the roots are x equals 5, x equals 2, and x equals 1. So they're our roots. So let's look at example 3. solving a cubic equation. So in example 1 and 2, we were able to use the fact that they had given us a factor or root already to find the quadratic and then to factorize the quadratic. But in this particular example, they haven't given us this. They've just given us a straightforward cubic and just told us to go solve it. So it would be useful if we were able to have that root or that factor. So what we do is we're going to use trial and error to find one of the factors. Well, actually rather one of the roots, which we will then turn into a factor. So it's important when we start one of these that we don't just start blindly going into this and thinking, oh, I'll just start subbing in 1 and minus 1 and 2 and minus 2. It's important to look at this number here. So this is minus 6. So one of the roots is going to be a factor of minus 6. Okay, so it's going to be a factor of minus 6. So let's look at that. So factors of minus 6. So we're talking about plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, so we should definitely have it within that. So if I basically look at, I'll try x equals 1. So I have 1 to the power of 3 minus 6, 1 squared, plus 11 by 1 minus 6 equals 0. So I want to verify that. So we're very lucky this time. We end up at 1 minus 6 plus 11 minus 6 equals 0, which basically gives me plus 12 minus 12 equals 0. So there x equals 1 is a root. Now we will not always be that lucky, and we would have to keep going. So let's just do x equals minus 1 just so we see what happens. So you'll have minus 1 to the power of 3 minus 6 by minus 1 squared plus 11 by minus 1 minus 6 equals 0. So this will be minus 1 minus 6 minus 11 minus 6 equals 0. So we have minus 12 minus 12 equals 0. So we end up with minus 24 equals 0. So x equals minus 1 is not a root. So we use trial and error. Now you don't have to go into that much detail and show that much of your workings. You can do it on the calculator. What I will say about the calculator work is be very careful where you're working with the negative number. If you put into your calculator minus 1 to the power of 3, most calculators will give you back minus 1, which is the correct answer. However, if you're working with minus 1 squared and you write just minus 1 to the power of 2, they'll also give you back minus 1, which is not correct, because remember, anything squared should be positive. So be careful when you're putting it into your calculator. Really get used to using your brackets to help you with that. So now that we have one of our roots, so we have x equals 1 is a root, which also means then therefore x minus 1 is a factor. So now that we have a factor, we can do our long division. So I've just cleared this screen here just so we have a bit more room. So what we have is we have x minus 1 is a factor. So now that I know one of the factors, I'm going to use my long division, divide this in to what I was given, so the cubic that I have here, and I should be able to get a quadratic, and then from that quadratic I should be able to factorize and solve, which will allow me to get all the 3 roots of the equation. So x goes into x cubed x squared times, so minus x squared, so that's our divide, multiply, subtract. Okay, minus 5x squared plus 11x minus 5x minus 5x squared plus 5x plus and a minus, so those cancel, and we're left with 6x minus 6, and that goes in 6 times, 6x minus 6. So we're going to just subtract and they cancel, so we have a 0 remainder, which is what we're expecting. So x minus 1 is most definitely a factor. If at this point you got a remainder, there's two scenarios. You've either incorrectly found the factor, so the factor is not correct, or you've done something wrong in your long division. So you do have that fail safe. So now that I have my quadratic, I'm going to go along and solve that. So I have x squared minus 5x plus 6 equals 0. So I'm going to use my guide number here. So my guide number is plus 6, so I'm going to use minus 3 minus 2. So x squared minus 3x minus 2x plus 6 equals 0. So x is common, so we're left with x minus 3. Minus 2 is common, we're left with x minus 3. So x minus 3 is common, we're left with x minus 2. So to work from these factors back down to our roots, we let each of our factors equal 0. So we get x is equal to 3. And here we let this factor equal 0, and we get x is equal to 2. So therefore, the roots are x equals 1, which we got earlier, x equals 2, and x equals 3. Just be really, be really clear here about your answer, because often these can be quite long. So, be helpful to whoever is correcting your paper, and, try and make your work as clear as possible by showing your answer at the bottom altogether, especially if there's bits of it dotted throughout. Okay, so let's look at example 4. So example 4 is solving a polynomial of degree 4, and this really will cover degree 4 or more. So if it was a degree 5, a degree 6, and so on. So I suppose, in my opinion, I don't think that an exam question would include a degree more than 4. I think it's very possible to get a degree 4, but anything more than 4, so if it was a degree 5 or degree 6, all you'd be doing is repetition, and I think that would be a waste of very valuable time at higher levels. So of course it is a possibility that they ask it, but in my opinion I don't think it is as important. So I think once you are familiar with the methodology, or with the way that we solve a polynomial of degree 4, and you know that this can be applied to higher degrees, and you practice some of these, that will be absolutely fine. So we're going to approach this like we solve a cubic. So we're going to look straight away at the last number here, so minus 144. And just like when we were looking at a cubic, that minus 144 is basically narrowing down the numbers that we're going to use for our trial and error to find the first root. So what we're going to focus on are the factors of minus 144. So that is plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 8, plus minus 9, plus minus 12, plus minus 16, plus minus 18, plus minus 24, plus minus 36, plus minus 48, plus minus 72, and plus or minus 144. Now, looking at that list, you might think, well, has it really limited it down for us? And no, I suppose it hasn't, but, well, we still have quite a substantial list of numbers to try. However, otherwise, we really would have been dealing with all the numbers from 1 to 144. So I suppose it has cut it down substantially, but it's still, I suppose, a much longer list than we're used to seeing. But just like a normal cubic, we will start at plus and minus 1 and just work through them. In these questions, they will usually be one of the first 3, so either plus minus 1, plus minus 2, or plus minus 3. So you wouldn't usually have to go much further than that, and I would say maybe double check your workings if you've gone beyond the first 3 that you've listed here. Okay, so in the previous example, we used a bit of workings, and there was about 3 lines for each. Now, given the number of factors that we have here, a table will probably be the easiest way to do this. So I'm going to use a table like this and fill in my values for x. So I'm going to try +1, then I'm going to try -1, then I'll try +2, then I'll try -2, I'll try +3, and I'll try -3. Now, if I find my root, I obviously won't continue. So we'll have 2, 1 to the power of 4, plus 12, 1 to the power of 3, minus 2, 1 squared, minus 108 by 1, minus 144. So when we evaluate that, that works out at 240. So we are trying to make sure that it equals 0. So this is definitely not a root. So let's work with -1. So 2 minus 1 to the power of 4 plus 12 minus 1 to the power of 3 minus 2 minus 1 squared minus 108 by minus 1 minus 144. And we evaluate that. And that gives us minus 48. So again, that is not a root. So let's work with 2. So we'll have 2 to the power of 4 plus 12 by 2 to the power of 3 minus 2 by 2 to the power of 2 minus 108 by 2 minus 144. And that evaluates to minus 240. So that is not the root. So let's work at -2. And when we evaluate that, put that into the calculator, we get 0. So that is our root. So there's no need to go any further. So what we know is x equals -2 is a root. And therefore, using our factor theorem, we know that then x plus 2 is a factor. So if you're not sure about the relationship between factors and roots, as I've said already, it will be a good idea to go back over that video. But where we have x equals -2, we can bring that -2 across the equals. It becomes a +2, and then that is our factor. So we're going to use that on this example. We know that x plus 2 is a factor, so if x plus 2 is a factor, we'll be able to divide that into our initial polynomial of degree 4, and we'll be left with a cubic, and then we'll be able to solve the cubic. So let's go on with that. So I've just cleared this to give myself some more space. So we know that x plus 2 dividing into 2x to the power of 4 plus 12x cubed minus 2x squared minus 108x minus 144. So this goes in 2x to the power of 3 plus 4x to the power of 3 here, and then we subtract, and we're left with 8x to the power of 3. Bring down the minus 2x squared, so that gives me plus 8x squared. Get 8x cubed here plus 16x squared. So we subtract. So what we're left here is minus 18x squared. We bring down the minus 108x. So here x goes into minus 18x squared minus 18x times. So we have minus 18x squared minus, and we have minus 18 by plus 2 is minus 36x, and we change our signs. So here we're left with a minus 72x, and we bring down my minus 144. So this goes in minus 72 times, so we get minus 72x minus 144, and we change our signs, so we're subtracting here. and we're left with no remainder, which is as expected. So we're now left with 2x cubed plus 8x squared minus 18x minus 72. So now we have a cubic and we're going to solve that as normal. Okay, so just have cleared the screen here so we have a bit more room to work. So the cubic which we were working, or which we had got to in the previous page, was 2x cubed plus 8x squared minus 18x minus 72. So now we're trying to solve this cubic. So we're going to use the normal steps for solving. So we're going to use trial and error again. So this time we're going to be focusing on the factors of minus 72. So those factors are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 8, plus and minus 9, plus and minus 12, plus and minus 18, plus and minus 24, plus and minus 36, and plus and minus 72. So just like in the previous part, we'll hope that and we should get this within the first few sets. So let's look at when x is plus 1, minus 1, plus 2, and minus 2. So what we're going to fill in is the 2x cubed plus 8x squared minus 18x minus 72, and then we're going to find what its value is and then whether it is a root. Okay, so let's go with this. So I'll fill this in just a lighter colour so we can see the difference. So 2 to the power of 3 plus a1 squared minus 18 by 1 minus 72, and the value then that gives us is 80, so it's not a root. So then let's sub in minus 1, say minus 1 squared minus 18 by minus 1 minus 72. So the value for this then is minus 48, so again not a root. So let's work with plus 2 to the power of 3, 8 multiplied by 2 squared minus 18 by 2 minus 72, and the value of that is 60, so again not a root. And then for minus 2 we'll have 2 minus 2 to the power of 3 plus 8 by minus 2 squared minus 18 by minus 2 minus 72, and we put that in, we get that as minus 20, so not a root, so we're going to have to keep going. So we're going to go with plus 3 and see how we get on with that. So we'll have 2 by 3 to the power of 3 plus 8 by 3 squared minus 18 by 3 minus 72, and that does give me 0. So yes, that is our root. Okay, so therefore x equals 3 is a root, and the follow on from that then is x minus 3 is a factor. So now we're going to use this factor and divide it into our cubic to find a quadratic, which we will then be able to solve for the last two roots. So remember, we have had two roots so far. So we've had a plus 2 and now we have a 3, a plus 3. So we have x minus 3, and we're going to divide this in to our cubic. So 2x cubed plus 8x squared minus 18x minus 17. So this goes in 2x squared, which is 2x cubed minus 6x squared. And we're going to subtract. So we get 14x squared, bring down the minus 18x. This goes in 14x times, so we'll have 14x, and we'll have 42x, and then we take that away. So the factors here are going to be plus 6 and plus 8. So we get 2x squared plus 6x plus 8x plus 24. So 2x in common, so x plus 3. And here there's an 8 in common, x plus 3. So now we have an x plus 3 in common. And that gives me a 2x plus 8. Remember that should be equal 0, so we get x plus 3 equals 0. In order to solve, we let each factor equal 0. We get 2x plus 8 equals 0, so 2x equals minus 8, so x equals minus 4. So the roots are x equals minus 4, x equals minus 3, x equals minus 2, and x equals 3. So x equals minus 2 was what we got at the very start. Then the second one we got was x equals 3. And then we've got our last two from here. So if this was a problem where the degree was more than 4, so if it was a degree 5 or degree 6, you do your first division. So let's take an example of degree 5. You do your trial and error and do your first set of division, and then you end up with degree 4. Then you do trial and error again, do your division again, and you end up with a cubic. Then you do trial and error again, you do your division again, and then you end up with quadratic. So you keep working and repeating that process until we get back to having a quadratic. And once we have a quadratic, then we can use our factorization method or our minus b formula to work out the final two roots.